Hello everyone. In this short video, I'll be showing you how you can use Excel to calculate central tendency indicators, dispersion indicators, as well as position indicators. Currently, I've opened a file, so I have a data set that relates to the price of homes. This is data that was obtained from a sample, and you'll notice that we also have other characteristics relating to each of the homes the file contains. Those of you who've watched the video on the data analysis toolpack have probably seen that the descriptive statistics option can give you many of the indicators we'll be discussing here through one click. However, if all you're interested in is finding, for instance, a mean or a median or a standard deviation, you may not want to open up that entire package just to find that one number. So Excel is actually quite intuitive when it comes to finding specific indicators. Now you definitely want to place yourself in an empty cell. You'll notice I've chosen a cell to the right of the data. Any insertion of functions requires that we start our formulas with equal. And if you're of the intuitive type, you may simply want to start typing the indicator you're trying to calculate. So for instance, I would like to calculate the average price of the homes, and not to say I'm taking a risk here, but I'll just try typing AVE, and you'll see all the options relating to functions that start with those letters. Average is the one that I'm interested in, so I'll double click, and then all I have to do is select the location of the data itself. So the data corresponding to the price of homes is in column A, so I'll select all of that data, close my parentheses. Notice at the top we have a screen to show what we've entered. I don't even have to scroll back up. I just close my parentheses and Excel will calculate the average. So my sample average, or my sample mean, shows a figure of 403,659. So that would be our average or our mean. You may want to write that down as you go along. Perhaps you're interested in finding the median, and as you probably have guessed by now, you may just want to start typing median, and you'll see the options Excel has for you. So you can then double click on the function median Excel is offering you, and once again select the location of the data. You can close your parentheses. At the top, again, you can confirm that that's what you want to do, or that's the calculation you would like to obtain. So median, 380,000. It's not abnormal for the median and the mean to be slightly different. Perhaps you wish to find the mode. Not that it's necessarily a good idea in this particular example, but mode, MO. Okay, and here is where you'll have, again, options. You may want to read, because mode returns a vertical array, mode singular, and there's mode. When you get images with little triangles, it means that this could be an outdated function, but it will work nonetheless. So mode, and I'll go and select the data. Close my parentheses. Okay. Keep in mind the mode is the number that is most frequently repeated in the data set. It might mean in this case that $332,000 appears twice. We are dealing here with a continuous random variable or continuous data. So there's no guarantee this number is repeated much more often than the others. Probably not a good choice anyway. When it comes to standard deviation, just like the other functions, you may want to start by an equal sign and write ST and look at the options. Now here also we have to be slightly careful because you'll see many different versions of standard deviations. Standard deviation P relates to the standard deviation for what is considered a population. You've probably seen in class that the formulas to calculate standard deviations are slightly different for populations than they are for samples. I was saying earlier that my data set is obtained from a sample, so I'll go ahead and double click on standard deviation S, and select the data. You can then go ahead and close our parentheses, and Excel will then show us the standard deviation, so $109,000. So it would not be abnormal, for instance, for a house to cost $109,000 more than the mean or $109,000 less than the mean. In class, we'll discuss in more detail how to interpret a standard deviation. Variance may be of interest. Fine. So variance is the standard deviation squared. So we're expecting a number that will be the square of the 109,000. And if we type VA, already the options start appearing. As earlier, variance P, so for a population, variance S for a sample. I'll go ahead and select variance S, sample variance, and select the data. I'm closing my parentheses, although you'll probably notice that even if you forget to close the parentheses, Excel will usually understand what you're trying to do. So here's our variance. In the first case, we were looking at central tendency indicators, mean, median, and mode. Standard deviation are dispersion indicators, as well as the interquartile interval or interquartile range. Now, quartiles themselves are position indicators, so I'll show you the two that you will be needing more than any other. There are the quartiles. There's Q1, so the first quartile is the number that is equal or greater than 25% of the data, and less or equal than 75% of the data. Now, quartiles start with a Q, so I think if we're taking a risk again, you can go ahead and type QU and see quartile exclude. That's the version we'll be using. A lot of the percentiles and quartiles have somewhat volatile definitions, so we're going to keep things standard and always choose the exclusive option. So I'm going to select that first choice, and then select the data for which I want to calculate the first quartile. And notice that in our options, there's one last indication that we have to include, which is which quartile we're looking for. So we're looking for quartile number 1. Right. So 332,000 happens to be the first quartile. It's a complete fluke that this number is also the mode. Perhaps 2 houses landed exactly on the first quartile. I don't have to show you where the second quartile is, because the second quartile happens to be the median. So I'll just go ahead and move on to quartile number 3. As the others, you can start typing and observe the options that appear. So quartile exclusive, and I'm going to select the data and then specify I'm looking for the third quartile. And the third quartile is obviously a bigger number than the first quartile was. The interquartile range happens to be the distance that separates the first and the third quartile. So if you're curious to measure how far apart the 2 quartiles are, you can actually just ask Excel to perform this measurement. So the interquartile range is a measurement of dispersion, somewhat different from the standard deviation because it measures the distance between 2 quartiles rather than calculate the root of the deviation squared or the average of the root of the deviation squared, which is what the standard deviation does. One last thing that I would also like to include are the percentiles. So percentiles are not different from quartiles in the sense that they are measures of position. In fact, quartiles themselves are specific examples of percentiles. Q1 is the 25th percentile and Q3 is the 75th percentile. So suppose we want to find here P10, so the 10th percentile. Again, using kind of an intuitive approach, we can type per and see what kind of options appear. Percentile exclude is the option we're going to be choosing here. So double click, and as usual we're asked to specify the array, so where the data is, and K is the percentile in particular we're trying to find. So first I'm going to select the data that interests me, so the price of the homes. And then in my option menu at the top, I will then add specifically which percentile I want. I want the 10th percentile. So 10% is actually 0.1. So if you type 10, we will get an error message from Excel, but if you type 0.10, meaning 10%, then no issues will occur. And here is our 10th percentile. Again, you're not surprised to see the 10th percentile is a number that is lower than the first quartile. If we wish to find the 90th percentile, same process. I will start typing in the function, select the one of interest and the data, the relevant data to the calculation I'm doing. And as an extension to my formula, I have to specify which percentile I'm interested in, so that's 0.9. And there we go, 545,000, which essentially means that this is the price of homes that is equal or exceeds 90% of the other prices in the sample. I hope this video was useful, and I'll be seeing you in later ones. Bye-bye for now.